Hello everyone. Today we are going to see about intelligent loose screw detection in Turk assembly line. This project presents in intelligent system for detecting loose screw in mechanical and industrial environment using sensors and machine learning. It used an ESP32 microcontroller along with the accelerometer and vibration sensors to continuously monitor motion and vibration patterns. To collect the dataset analyzed using a machine learning model to distinguish between normal or faulty conditions. By identifying abnormal vibration causes by loose screw, the system can generate yearly alerts helping to prevent equipment failure, reduce maintenance cost, and improve all over system reliability. This approach combines IoT and AI to provide a smart, cost-effective solution for real-time production maintenance. Yeah, here you can see this is the black diagram for hardware. We have two screws, so accelerometer 1 and accelerometer 2, as well as vibration also. For two screw we are using vibration sensors, and the power supply. For power supply we are using lithium battery, and then microcontroller we are using as ESP32. Through Wi-Fi connection we are sending values to ML. By using ML we are predicting whether the screw is loose or normal. Let's see the software black diagram. Here you can see by using that sensors, accelerometer data and vibration data, we are sending to ML part by using IoT API. Through this API link, we are sending that values. That values will collect and pre-process. Once that values will pre-process, it will store in SQLite database, and then whatever the data stored, it will label and create as screw 1 and screw 2, and then by using random forest we are analyzing that whether that screw is normal or abnormal. As well as in web page we can see that results, and then as well as whatever that values fetching from hardware we can see that in dashboard. Let's see the train code. These are the libraries for our project. Here you can see this is our dataset path. We need to load our dataset, then converts to numeric, that vibration sensors and accelerometers. Here we can see for that conditions we are using, and then screw 1 and screw 2 label we are using accelerometers, and then we are splitting our dataset into 20 percentage and 80 percentage. Here you can see for 20 percentage it will goes for testing, and remaining 80 percentage it's for training. And then here we are using random forest algorithm. Once that model learn, it will save in this model. Here you can see .pkl. By using this .pkl model only, we will test our values in app.py. Here you can see app.py is nothing but backend and front end. We are integrating both backend and front end. Here you can see these are the libraries, and for front end we are using Flask, and for database storage system we are using SQLite 3. This is our API link. Here you can see by using this link only you will fetch values from hardware, as well as they have one link. They'll send it values from hardware, and by this link we will fetch values. And here you can see for table creation we are using SQLite 3. While enter into a page we need to give username and password for register and login. To store that we are using SQLite 3, and then accelerometer and vibrations we need to create a table, and then we need to show that values. For that we are using SQLite 3, and then here we have given accelerometer values and accelerometer 1 values and accelerometer 2 values. If that value is satisfied, then the screw is now normal, or else if that value is abnormal, then the screw is loose screw. Then to fetch values we are given some conditions. Here you can see, and every 3 seconds will fetch values. Here you can see, and then these are the routes: home button, about button, analyze button. And in analyze button we have start. Once we started it will fetch values and it will store in that, and once you stop the status will stop. And to get API link from that hardware we will fetch values. So for that condition, and in web page we have delete button. We don't want any values means we can delete all values. Here you can see, and then register button, and then login. In register button, we need to give username and password, and it will store in user DB. Here you can see database.db. Once it's stored, it will goes to redirect to login page, or else it will redirect in same as well as in register page itself. And then once it goes to login page, again you need to give username and password, and that it will goes to our database, stored database, and it will search whether that username and password is correct. Once it correct, it will goes to our analyze page, or else it will redirect to in login page. Let's run this code. Now here you can see this is our home page, and here you can see register button and login. Once you are login, you can analyze this page. I have already login. So this is our login page. This is our analyze page, and here you can see components, hardware components. This is vibration sensor, accelerometer for screw 1, and for screw 2 vibration sensor and accelerometer you can see, and ESP32 accelerometer and vibration sensor, it will send values to ESP32. From ESP32 we will fetch values in software. Here you can see here you can see abnormal activities. The screw is loose, so it's showing as abnormal. Yeah, here you can see now two screws are normal. Here you can see it's showing as normal. Accelerometer and vibration sensor for screw 1, and screw 2 accelerometer and vibration, and two screws are normal. Here you can see. Yeah, here you can see for screw 1 abnormal activity. Here you can see. So then the screw is loose. If I leave means it will come as normal. Yeah. In about page you can see whatever we have used, whatever hardware components we have used, and for technologies in software whatever we have used. Here you can see. And this is our home page. That's all about our project. Thank you.